Welcome to TSAT. Today I am going to discuss about space technology. So, in the case of space technology is considered, space technology is the technology developed by space science or the aerospace industry for use in space flight, satellites or space exploration. Space technology includes spacecrafts, satellites, space stations and support infrastructure, equipment and procedures. So, these are all the different areas where space technology is involved in. But today I am going to discuss about space technology where communications are involved in terms of satellites. In this context of communications is considered with the help of satellites, we need to understand certain aspects of space technology in the process of communication. So, what are the different components which we need to understand regarding space technology? So, the different areas which we need to understand communications with the help of space technology are, for example, we need to know about different variant types of satellites, we need to know about different variant types of orbits, we need to know about different variant types of vehicles which carry satellites. So, in this context, when we are clear with this, we will be able to understand how communication happens with the help of space technology and what are the different applications of this space technology for the purpose of communications we are going to discuss. So, the upcoming we have got different topics regarding space technology in terms of application of space technology in the development of agriculture or industry, communications, etc. There are many different aspects being given in the syllabus. So, to understand how space technology is applicable in these areas, we need to know what this technology is, how this technology has been applied. So, in this session, I am going to make you clear how this infrastructure for space technology exists for solving all these problems. In this context, we need to know what a satellite is. A satellite is an electronic system which is placed in an orbit, which contains transponders and electronic systems where the satellites have got the capacity to radiate certain frequencies of electromagnetic radiation like radio waves, or they can even receive the electromagnetic radiations. So, in this process, the signal is being used for the purpose of communications. So, because we have got different electronic systems like microphones, etc., which can convert one form of energy into another form of energy. Sound energy, the microphone may convert it into mechanical energy into an electromagnetic wave or electrical signal. So, in this process, what is happening is the satellite transmits the information to you with the help of electromagnetic radiation. So, this satellite is kept in an orbit. An orbit is a circular or elliptical path in which an object moves. So, here in this case, a satellite need to be launched into an orbit, and the satellite is an electronic system containing electronic systems like transponders, which can not only radiate electromagnetic radiation like radio waves, they can also receive the waves based upon the bandwidth and frequencies and variation of the electromagnetic radiation. The information can be decoded by certain softwares to understand and translate into an understandable language. So, the information received from the satellites will be of different variant informations about meteorology, weather forecasting, or about the surveillance in terms of security aspects, resource identification. These are different applications of the information which has been acquired through the process of satellite communications. For this, we need to launch a satellite into an orbit. So, the satellite revolves around the Earth in an orbit. An orbit is a circular or elliptical path through which the satellite moves. So, how come a satellite can move in an orbit is a question. Because an orbit is a circular path. For an object to be in a circular path, there are certain forces need to be balanced. The two forces which need to be balanced for an object to be in a circular path is the forces are centripetal and centrifugal force. Centripetal force is a force which is acting towards the center of the circle. Centrifugal force is a force which is acting away from the center. So, here in this case, as far as the orbit of the satellite is considered, when it is moving or revolving around the earth, the gravitational pull of the earth acts as a centripetal force. So, if the centripetal force dominates, the satellite falls on the earth. So, to overcome this, centrifugal force, which is exactly equal and opposite, is exerting on the satellite, which when the two forces, centripetal and centrifugal force, are being balanced, the satellite will be in an orbit. So, my question is, what is the source of centrifugal force? You know, the source of centripetal force is the gravitational force. The source of centrifugal force is the rocket which you are using to launch provides a thrust working against the gravitational force, is the centrifugal force being generated. And this rocket releases the satellite into a desired orbit with a certain velocity. So, the velocity with which a satellite need to be released into an orbit varies from altitude to altitude. So, for example, when the orbital altitude is low, when relatively compared with an orbital altitude which is higher from the surface of the earth, the velocity with which you need to release a satellite into the orbit is not the same. In a lower altitudinal orbit, the satellite need to be released with high velocities, because with the proximity, when the distance is less, the satellites are more impacted to gravity. The gravitational pull is more when the altitude is less. So, the velocity with which you release the satellite into the orbit must be more. So, with the increasing in the altitude, the gravitational impact or the sphere of influence of gravitational field of the earth with the increasing in the altitude gradually reduces. So, consequently, when the centripetal force, the pulling of the center by the gravity, when it is reducing, correspondingly the centrifugal force must also be less. So, the velocity with which you need to release a satellite into the higher altitude orbit must be less. So, in this process, what happens is, when the satellite is revolving around the earth, the time duration consumed by a satellite to revolve around the earth with increasing in the altitude increases. In the low earth orbits, it is around, low earth orbits are around 400 to 500 kilometers or so, because of the less circumference of the orbit, one, and the velocity of the satellite is more in the low altitude orbits. The time consumed is less. It can make a revolution approximately around 1.5 hours or 90 minutes. With the increasing in the altitude gradually, what happens is the time consumed gradually increases, because of the circumference of the orbit is more and the velocity decreases. Gradually the time consumed increases. So, at an altitude, the time consumed will be 24 hours for a complete revolution. This altitudinal orbit is being described as geostationary orbit. So, in the geostationary orbit, you have got only one orbit at this altitude, at 36,000 kilometers above, where the revolutionary velocity of the satellite is exactly equivalent to rotation of the earth. So, this geostationary orbit is vertically above the equator, 36,000 kilometers away, and you have got only one orbit, and the geostationary orbit is circular orbit. So this is how, with the variation of altitude, the time duration varies with the satellite. A satellite is a freely falling body, where always centripetal and centrifugal forces balance, because of which, for the purpose of revolution of the satellite around the earth, there doesn't require any fuel. That is one of the major aspects which you need to keep in mind as far as the energy requirement of satellite is considered to revolve around the earth. So, in this process, depending upon the technological variation and requirement, all the orbits are not being oriented in the same direction or plane. So, different satellites are being loaded into different variant types of orbital planes. So, what are they? We will be discussing before completing what satellites are. So, as you have come to know that satellite is an electronic gasket generating electromagnetic radiation for the purpose of communication. Satellites have been classified into IRS and INSAT variants of satellites. IRS variant of satellite is IRS means Indian Remote Sensing Satellite. Remote sensing means sensing sensing some information from a region where you cannot access it physically. So, which is known as IRS satellite. So, Indian remote sensing satellites are satellites which are for remote sensing. The information from that remote region where physical access is not possible for you, the information can be anything. The information can be the kind of weather forecasting or the kind of low pressure trough or a cyclone being developed in the Bay of Bengal or Indian Ocean or Arabian Sea, or it can be about the formation or the way the monsoons are being formed, or it can be about the spying conditions, or it can be about, it can view about the way the infiltration of terrorists in the borders of our country, or it can even gives you information regarding the distribution of resources, across the country and the world. So, the remote sensing purpose might be to identify a resource, to identify an enemy, to weather forecast, or any other activity. It can be classification of vegetation, identifying the extent of crop area being cultivated. So, the information is highly diversified depending upon your requirement. For these purposes, remote sensing satellites are being used. In the case of INSAT variant of satellites, INSAT stands for Indian National Satellites. These Indian national satellites are basically used for the purpose of communications. For example, direct to home, you have got dish TVs in your home. So, the information is received by these televisions at our home is through INSAT variant of satellites. In this case, after knowing the main basic class of these satellites, so as part of current affairs, you might be knowing that different variant names will be given, OceanSat or EduSat. These are different variant names of these, either of these satellites. The names to those satellites are being given in terms of the name of the program, or INSAT 2, or some prefix will be, suffix will be given, added to this INSAT or IRS. This suffix is the name of the satellite. It indicates the time duration of launch, technology involved, purpose, aims and objectives. It is always, the suffix can be said as the name of the satellite, which indicates its characteristic features. Otherwise, every satellite being launched will be either IRS or INSAT. These satellites in the orbit are being launched by rockets. A rocket is a vehicle which carries the satellite into the orbit. So, here we have got different variant types of vehicles. So, in the initial days of the ISRO formation, SLV, satellite launch vehicle, and augmented satellite launch vehicles are the incipient initial mode of rockets which we have made. Now ISRO is not using these kind of vehicles. Now we are using polar satellite launch vehicles and GSLV, geosynchronous launch vehicles. An advanced variant of GSLV is GSLV Mk2 and GSLV Mk3. So, and SSLV is small satellite launch vehicles. So, these are the three variants right now which are being used by ISRO. Polar satellite launch vehicles, the name itself says that this is a rocket which launches the satellite into an orbit where the orbit is incoherent with the north pole and the south pole of the earth. So, if this is the earth, if this is north pole and south pole, the orbit is incoherent to the north pole and south pole. So, this is known as a polar synchronous satellite or an orbit into which PSLV launches the satellite into these orbits. geosynchronous launch vehicles launches the satellite into orbits known as geosynchronous orbits. Geosynchronous orbits are orbits where the satellites move in the direction of Earth's rotation more or less above the equatorial region. So, the purpose of these two satellites are different. One is for remote sensing, the other is for communications. Small satellite launch vehicles are vehicles which are used to launch nano small satellites into low Earth orbits. Those are experimental purposes and research purposes to encourage students from different universities. These are also used for these different kinds of experimental purposes also. So, now I have explained you the orbits. Orbit, as you know, is a circular path through which, or an elliptical path through which a body moves. So, depending upon the orientation of the orbits, orbits are being classified. So, how these are being classified? So, in the case of this orientation of these orbits, for example, this is a polar orbit, the blue color one, where the satellite moves in coherent with the North Pole and South Pole, is known as polar synchronous orbit. These polar synchronous orbits are low altitude or and relatively compared with geosynchronous orbits or geostationary orbits. Polar synchronous orbits altitude is low. They can be up to an altitude of 1200 kilometers to 1500 kilometers. So, these are being described as polar synchronous orbits, where PSLV is a vehicle which is used to launch polar synchronous satellites into polar synchronous orbit. So, some of the remote sensing satellites are being launched in polar synchronous orbit. So, these orbits are classified on the basis of the orientation of the plane of the orbits respective to the Earth. Polar synchronous orbit is oriented in synchronous with the North Pole and South Pole. That is the reason why it is known as polar synchronous orbit. So, in the case of geosynchronous orbit or geostationary orbit is a variant of geosynchronous. So, which is revolving around the Earth in the direction of Earth's rotation above the equatorial region. So, now with this diagram you might have differentiated between polar synchronous and geosynchronous. So, all geosynchronous satellites are not geostationary, because when the altitude of the geosynchronous orbit is less than 36,000 kilometers, the time duration consumed by the satellite to revolve around the Earth will be less than 24 hours. So, this altitude, at the altitude of 36,000 kilometers or 35,786 kilometers, some approximate variation you will be having. So, this is an orbit. This orbit is also known as Clarke's orbit, because first Clarke is the one who has first hypothecated imagined the existence of geostationary orbit. Later it is been proved. That is the reason why this orbit also is being named on behalf of Clarke. So, in the case of geostationary, as I have mentioned, the satellite revolves around the Earth equivalent to the velocity of Earth's rotation. That is the reason why it seems to be stationary, even though it is not. Relative to the surface on the Earth, the satellite seems to be stationary because they are moving with the same velocity. So, the advantage with geostationary satellite is always a satellite will be available to you for the purpose of communication. 24/7 communication has been possible with the help of geostationary orbit. So, this is the fundamental difference between polar synchronous orbit and geosynchronous orbit. So, PSLV is a vehicle which launches the satellites into polar synchronous orbit. GSLV is a vehicle which carries the satellites to geostationary or geosynchronous orbits. The third variant of orbit is low inclined orbit or highly elliptical orbit or Monlier orbit. These are the synonymous words. This is a this has been described as a highly elliptical orbit because, so this is what the real-time orbital time duration of a Monlier orbit, or otherwise also known as highly elliptical orbit, is considered. It is neither polar synchronous nor geosynchronous. it revolves around the earth at an inclination plane at a 63 degrees, and the revolutionary time duration of this orbit is 12 hours. So, this is a substitute to geostationary orbit. So, why this is considered as a substitute to geostationary orbit? Because there are certain limitations in terms of geostationary orbit. The limitations are the number of orbits available in terms of geostationary orbit is considered. It is only, you have got only one orbit, and the number of satellites which can be loaded into this orbit is limited. You cannot load more than 180 number of satellites. So, the reason behind it is, if you are loading more than the required essential number of more than 180 number of satellites, while the satellites are transmitting the signal because of a huge footprint satellite has got. See this, geostationary satellite has got a footprint, almost all it covers 1/3 of the surface area of the earth. So, when you are placing more number of satellites, the footprint intercepts with one another, leading to destructive interference of waves, leading to failure of signal transmission. So, to avoid the interference of signal transmission, you need to limit the number of satellites need to be loaded into the orbit in terms of. So, these are some disadvantages as far as geostationary orbit is considered, in terms of the number of satellites which can be loaded, and very high altitude. The signal strength dissipates by the time it reaches the earth because of very high distance, and the signal distortion happens because in temperate latitudes, because the angle at which the signal need to be transmitted when you are moving from equators to the temperate latitudes and the higher latitudes, what happens is the angle with which you need to project, because these are vertically above the equatorial regions. So, when you are projecting the signal to temperate and higher temperate latitudes, subpolar latitudes, the signal gets distorted, and by the time the signal reaches is not so strong. These are disadvantages. To these disadvantages in terms of the number of satellites loaded into the orbit are limited. One. Second, signal strength. Molniya orbit is used as a substitute to geostationary orbit. So, which focuses much on the northern temperate latitudinal countries, focusing on the developed countries like the United States or the European Union or the Japan, China, or in these latitudes. So that what happens is, these satellites in the orbit substitute the process of communication, because there is a limitation in terms of the number of satellites in the geostationary orbit. So, the other advantage here is the time duration of the revolution of satellites in Molniya orbit is 12 hours. So, in a day, a satellite in a Molniya orbit will be able to do 2 revolutions, means the orbital ellipticity is set in such a manner where it is spending only a couple of hours in the southern hemisphere, rest of the 10 hours are spent in northern hemisphere, so that to the northern hemisphere a satellite will be available for 20 hours in a day. So, it is a substantial amount of time in a day where communication is being made possible, substituting geostationary orbits, geostationary satellites. This is the main advantage with the Molniya orbit. So, orbits are also been classified in terms of altitude. So, low Earth orbits, when the altitude is around 400 to 500 kilometers. Medium Earth orbits from the range of 1200 kilometers to 20 to 25,000 kilometers. High geosynchronous Earth orbits, approximately around 35,000 to 36,000 kilometers are considered as these different class of orbits, but the altitudinal range is not so rigid and watertight compartments has been described. There is any number of orbits from this altitude can be formed consequently till geosynchronous orbits. So, On the basis of altitude, this is the way they are being classified. In this context, we need to know what is a GTO. GTO is a geotransfer orbit. GTO is a temporary orbit into which satellites are being loaded. The PSLV or GSLV cannot carry the satellites directly to the orbits. PSLVs and GSLVs launch the satellites into GTO, known as geotransfer orbit, which is a low Earth orbit. The reason behind it is why they cannot carry, because the amount of fuel being consumed to carry the satellites from the surface of the Earth is so huge that because the gravitational force on the surface of the Earth is so maximum that it consumes a lot of fuel. By the time we place the satellites into GTO, geo transfer orbit is considered, with the increasing in the altitude, the sphere of influence of Earth's gravity gradually reduces. So, with low energy, they can be raised to the desired altitude by boosters which are being pre-arranged before launching the satellites attached to them, like taking a slingshot projections. For example, when they are revolving around the ellipticity, what happens is at a certain point the pre-arranged boosters. So, there is a pre-arranged booster. This is for example, assume this as a GTO, geotransfer orbit. To this geotransfer orbit, when a satellite is being loaded, a pre-arranged booster is being fired to eject from the lower orbit and raising to a higher altitude orbit. So, in the same way, this phenomena is being made many number of times to raise the altitude of the satellite to the desired altitude so that it starts functioning. So, GTO is a temporary orbit which is being used for launching the satellites temporarily to overcome the gravitational force. So, these are different variant types of orbits, and now you have come to know the different variant types of satellites and different variant types of vehicles, PSLV and GSLV. So, these are the 5 different class of rockets being used. SLV and ASLV are not in use now. PSLV, GSLV Mk2, GSLV Mk3 and SSLV are the different variant types of rockets being used to launch satellites. In this context, the signal is being transmitted with the help of electromagnetic radiation. So, in this context, what is meant by electromagnetic radiation? Electromagnetic radiation is a wave which carries electrical and magnetic energy. The electrical and magnetic energy are carried by a fundamental particle known as photons. So, these photons carrying electrical and magnetic energy move in a wave form to carry the energy. So, the electrical energy and the magnetic energy are perpendicular in an electromagnetic radiation. For example, light wave is part of electromagnetic radiation which contains electrical and magnetic signals. These electrical and magnetic signals in the electromagnetic radiation is being used for the purpose of communication, because one form of energy can be converted into another form of energy. So, in the bandwidth of electromagnetic radiation, visible light is in between the electromagnetic radiation in this total bandwidth where the frequency and wavelength gradually varies. So, here towards the end of the electromagnetic radiation, we have got radio waves. So, the radio waves are made contains electrical and magnetic energy carried by photons. In the same way, the gamma radiation, X-rays contains photons, but because of the variation in the frequency, the amount of energy available in the electromagnetic radiation varies across the bandwidth. At gamma radiation, because of high frequency and low wavelength, the intensity of energy is very high, and by the time gradually when we move towards radio waves, the energy is less and the wavelength is more. In this, the visible light is in between, having a bandwidth range from 0.7 to 1 mu, 0.3 to 1 mu, or 400 nanometers to 700 nanometers, where visible light is part of electromagnetic radiations. So, friends, we shall meet in the next session discussing another topic in science and technology. Thank you.